And make sure that you need to log on to the Blackboard here. Blackboard. Oh, hold on. So you go to the class website. Find the stats class. Then select, for example, chapter 6. You'll be able to see the lecture notes for this class, the PowerPoint, and also the Excel worksheet here, or workbook. That's the stats abacus for normal distribution and also binomial distribution. But for other chapters, like chapter 5, for example, you will be able to see what chapter 5 lecture notes and chapter 1 to 4 review. I did a review video. Chapter 5 lecture video part A and also part B. Okay. The same thing for tonight. I'm going to post probably 2 video clips. Well, the first one is for normal distribution. The second one is for the binomial distribution. Okay. So now let's move on to binomial distribution. Oh, I have here the heights of adult for a normal distribution 5.8, 5.8, and 0.4 standard deviation. So there are two questions here. Let's see how to solve this. One is, what percentage of her customers are taller than 6 feet? Taller than 6 feet. So if we draw the 6 feet. So in this case, we know the mean and standard deviation, and we're trying to find what is 5.8, 0.4. So we know the standard deviation for this one. So it's normal distribution 5.8. 0.4 is the standard deviation. We're interested in finding out what's the probability is x is greater than 6.0, yeah, 6.0. And but we have to, if you look at it, if you just use Excel, this will tell me I need to find out what 1 minus 1. Because Excel probably will give me, because the mean here is what, 5.8, and the 6 is here, right? 6.0 is here. So I'm interested in what? I'm interested in this area. But Excel will give me what? The red area, right? Excel. So I have to use 1 subtract the red area, which is what Excel gives to me. So 1 subtract, I believe it's normal distribution, and x is 6.0, comma, mean is 5.8, standard deviation is 0.4, and 2, right? Accumulate. So you'll find the probability, right? Yes. But if you use my abacus, and also you will be able to find the z-value, right? Because if you look at the graph in the quiz, sometimes you need to know whether the z-value is a positive number or negative number. To find the z-value, it's actually pretty easy, because for the 6 to convert to z-value, all you need to do is subtract the 5.8, subtract the mean divided by the standard deviation, divided by the 0.4. Okay. Or we can use this, the abacus. So the mean is 5.8, standard deviation is 0.4, and I'm interested in the x is greater than 6. Oh, no, 6 here. So you can see the z value is 0.5. It's a positive number. Okay, and this is the probability. This is the probability. But if you look at the graph, if you look at the z value, it will be the area greater than 0.5 in the right tail, right tail. Okay. Second part, be very careful. Wants to cater to the tallest 20% of men. So what's the cutoff? Tallest 20%. So if we use Excel, not using my worksheet here. I mean, even if you use my worksheet, what percentage should we put there? Tallest 20%. Well, maybe I have to draw this.
We put in 80%?
Yes. No, so in this case, we know a normal distribution with a normal distribution 5.8 is the mean, and 0.4 is the standard deviation.
Yes.
So we are interested in, okay, this is the distribution. The 5.8 is here. Now the question is, okay, what is this x value? Will give me the 20% here. Yes. However, Excel, if we use the inverse whatever, Excel will only give us which area? The area. Wow. The area to the left, yeah. The area to the left. Will give us this area. So in this case, if we use Excel, we use norm inverse because we know the probability, yeah? And then the probability, instead of putting 20%, we have to put a what?
80.
I always put the area on the left side, which is 80%. And then standard mean, standard deviation. It'll give us this value. Is that clear? 80%. So it's very easy to make a mistake. Top 20% is what is here. Like SAT, top 1%, or 99%. Well, 90%, well, SAT is easier, so 99% is here, right? But how about if I say what is the probability in the test 1 for this class, you have the top 5%. Then what's the cutoff score? Then if you use Excel, you have to put 95 because Excel will give you this area. Good?
So does that actually mean the next page, the example,
Yeah.
20 versus the 80% is wrong?
Let's take a look at. Ah. It should be 80% here. Hold on. Any other mistakes? Remember? Any other mistakes in this? Which one?
Oh, that's 62.
Oh yeah. Which one? Let me. I probably will.
That's a while back.
Hold on.
Women's height example.
Oh yeah. 60.
Yeah, 61.
Yeah, no. 60. Hold on. No.
Oh, slide 29.
Okay, slide 29. Hold on. 62. Yeah.
Yes, sir.
Okay. I'm going to save this at the end of class. I'll upload. Thank you. Sorry. No, this is a very significant mistake here. Good. Yeah, so should have put 80%. And I believe 80% will give us the, yeah, just, oh, hold on. Let's find out what's the probability. 5.8, 0.4, top 20%, yeah, 20%. Oh, we'll put 80%, yeah.
What it means in this.
The mean is 5.8, hold on. Mean is 5.8, 0.4, so sorry, this should be, yep. What's on 6.1366? 6.1366. Okay, but we'll have to put 80%. The top, yeah, definitely, that's all. Okay. Okay, good. Are we ready for the binomial distribution? Binomial distribution actually is pretty simple. Now, what is a binomial distribution? What? Yeah, this slide should still be part of this one. Yeah, that's all. Okay. Okay, binomial distribution. Binomial distribution, the outcomes are discrete. Like you shoot a basketball, 3 out of 5. You shoot 5 times. You make 3 out of 5, 2 out of 5, 1 out of 5. Okay. Or you are planning to have 3 children. The outcomes will be 1 boy, or 2 boys, or all boys. Yeah? Those kind of things. And also, for each trial, there are 2 possible outcomes. You make it or you miss it. Boy or girl. To be or not to be, right? To be. You pass or fail, right? Pass or fail. Oh, man. But there's no possibility for you to take an incomplete, right? Incomplete. Either pass or fail for binomial distribution. Only 2 possible outcomes. If there's more than 2 possible outcomes, it's not a binomial distribution. Okay. And the probability stays the same. Like if you toss a quarter 5 times, so the outcome is what? 1 head, 2 heads, 3 heads, 4 heads, 5 heads. Yeah. But each trial, there are 2 outcomes, either head or tail. And in this example, the probability is the same, 50%. When the first trial, it's 50% chance of getting head. Second trial, still 50%. And also the trials are independent. The trials are independent. Right? If you try twice, so the first trial will not affect the outcome of the second trial. Because this is easier. We try 8 times, yeah? 8 times. And also, each trial has 2 outcomes, head or tail. The probability of getting a head is the same. And each trial is, all trials are independent. Right? Independent. Okay. And the shape of the binomial distribution, if you take a look, depending on the both n, what is the n? The number of trials. The total number of trials. Like you shoot a basketball 10 times. P is the probability of success. So this is an example of n is equal to 15. You try 15 times. The probability of success is 30%. So you can see it's this is the right tail, right? Mm-hmm. This is not a center, right? This is not like a normal distribution. It's skewed to the right because the tail is on the right. Yeah, the tail is on the right. The head is here, right? The head is here. The tail is here. But if we're changing the numbers, you can see changing the numbers probability of success to 50%. Then you can see this is similar to a normal distribution. But if you have a large sample size, if n is 100, you try 100 times, And even the probability is 0.3, you still see a normal distribution. Normal distribution. Okay. So let's take a look at this example. 47% American. So that's the probability of success, right? The probability of the event, okay, the outcome. So a random sample of 200 Americans. So find the probability that exactly 90 Americans say it is important to control. 90 out of what? 200? And but each person has a 47% of chance to say yes, right? So the n is 200, two outcomes. Yeah, the probability of success remains the same, 47%. Then we can use the binomial distribution. The notation is the first number is what? N, the number of trials. The second number is what? The probability of success. The last one is what?
What you're trying to find.
Exactly, the x. Yeah. If 90 out of 200, x is 90. Okay. So we can use, it's called a binomial distribution, BINOMDIST. And again, there are how many? There are four. There are four instruments here. The first one is the number of numbers. Okay. So that's the number of success in trials, like 90. Yeah, 90 out of 4. Trials is the second number is trials, the total number of trials, 200. So 90, comma 200, comma 47%. Then the last one is true or false. If you select true, it's a cumulative. Cumulative what? A cumulative distribution matters for a discrete outcome. So cumulative, so if I select yes, then what does that mean? It gives me the probability from 0 number of people all the way to 90. 90 people, right? 90 people. So it gives me the probability from, you survey 200 people, the probability of saying yes for 0 all the way to 90 people, right? So that's a cumulative. But if you select cumulative as false, then the probability will give us exactly what's the probability that 90 out of 200 people will say yes. You see the difference? So if you select the cumulative, that means what? If you select a cumulative, I'm too tired to switch the cumulative. So that means it is we're trying to find the probability. We're trying to find the probability of the probability of less or equal to 90.
No.
Right? Cumulative.
Exactly 90.
No, if the cumulative for the cumulative, the first instrument, if you select true.
Oh, okay.
If you select true, then this is a cumulative. So that basically the cumulative is true. So that means this will give us. So that means the cumulative is true. Cumulative probability distribution is true. Okay. So this will give us the probability of the probability of x is less or equal to 90. But if you select the cumulative is false, so cumulative is not true. And then that's the probability of x is equal to 90. You see the difference? Okay, clear. Thanks. So let's take a look, take a trial, yeah? The question tells us what? 90, yeah? 90. Exactly 90. You ask 200 people. Exactly 90 say yes. But each person, on average, 47 people will say yes. Then you put 4 numbers, binom, B-I-N-O-M dot D-I-S-T. And so we can try this. 90.3. Why 0.3 here? Sorry. Do you have any? It shouldn't be 0.3. It should be 47%, right? I must be doing something last night. Hold on. Yeah? It should be 47.
0.47.
Whoa. Control Z. Hold on. Oh, let's make the font a little bit smaller. Sorry. 32. That's too big. 28.47. Yeah. Let's try. So that's equal to by, you see binomial, by norm dot dist. So the first number is 90 out of 200, 0.47, and false. Yeah, we want to know exactly 90. Exactly. Is this FALC? Yeah. Anyways, this should be 0.47. I'll upload the again.
I think that 100 is supposed to be a 200.
Which one? Yeah. Oh yeah. I'm not sorry. Next time when I'm watching MBA and typing. Okay. One more question though here. Okay, so that's the probability, yeah. You see the probability 10.2%. In other words, for each person, right, random select person, the chance is to be unemployed is 10.2%, right? So you randomly select 15 people. What is the probability that, okay, 3 or fewer were unemployed? Less or equal to 3. Now, this is what? Perfectly what? Less than, fewer, 3 or fewer is what?
Cumulative.
Cumulative. Can be 0, 1, 2, 3, cumulative. So in this case, 15 trial, okay, this is I mean, actually, you can find each one of them. What's the probability? 0 person unemployed, 1 person employed,
Yeah,
2
percent.
and 3 people unemployed. And then we add them together. But you will get exactly the same result if you type in what? If we type in here, sorry, I need to hold on. Insert text. This will be exactly the same as what? Text. It will be exactly the same as if I type equal to binom.dist, then 3 or less, yes. 15 trial. Each person has a 10.2% chance of unemployed, and 2. And you will find it's exactly the same probability. 2. Yeah, sorry about this. Okay. For oh boy. 20. Okay. Oh, what I'm doing here? I tap. Okay. I have it here. Anyway. Sorry. Then I have to actually remove this, yeah? Yes. Yeah, I have it here. Sorry. Okay. And how about more than 5 means what? 6, 7, 8, 9, yeah? 5 or more. You include what? 5. Is that clear? It matters if the outcomes are discrete. Okay. Okay, now let's take more than 6, greater than 6. Fewer than 5, less than 5. At least 7, 7 or less. Between 3 and 7, that's easy. 10 or more, or at least 10, right? At least. So let's take a look at this medical coverage. Only 11%. Yes, that's the probability. So you surveyed 80 people. So find the probability that more than 15. Wow. How do you do more than 15? Wait. How do you do more than 15 out of 80? So we have a calculator what? Because Excel will only give us a what? If you choose cumulative, it will only give us from 0 all the way to 15.
So 1 minus.
To the inverse.
1 minus, yeah, 1 minus, but still be careful, it's more, yeah, 1 minus, exactly. 1 minus whatever Excel gives us, right? Because if you use Excel will give, sorry, I have to whoa, how can I jump to the first slide?
You hit something. That's
I know. Okay, sorry, what was the example? I forgot.
11% of Californians lack medical
Yeah, how many
insurance.
people survey 80? The question
yes,
is-
80 survey.
Uh-huh,
Find the probability that more than 15 lack medical
15, yeah.
insurance.
More than 15, yeah.
Mhm.
Okay, more than 15. Yeah. See, the Excel will give us this is the probability, yeah? From 0%, 1, 2, 3, 4, 5, all the way to 15, and all the way to 18, yeah? 18. Excel will only give us what? To the left, to the 15, yeah? Or including at 15. So if we find the probability that more than 15 to 80, yeah, then we have to 1 minus what? This. 1 minus this. So that's the whole idea. So I have it here. Oh. Sorry. The smaller one, small chalkboard is much easier, yeah? Oh boy, hold on. It's out, but anyway, it's algorithm, hold on. Sorry, oh boy. I can't believe, oh boy. But this is not an art class, that's okay, sorry. Okay. So if you look at here, yeah, so basically, yes, you can see 1 minus the whatever Excel gave us, 15, 80, the probability, and the cumulative is true. How about between 10 and 20? Between 10 and 20. Can we first find 10 or less? Yes, by using Excel. Can we find 20 or less? Then in between is what? You take a difference, right? You see the in between is you take a difference, right? You take a difference between the two. And the good thing is I have Excel built up for you. And basically, well, I'm trying to put all the way to 100 because most of the questions probably will not go to 100. And so in our example, it's sample size is 80, yes, and the probability is 10.2, yes. Oh, 11%. Yeah, 11%. Yeah. So I'm changing this to 11%. Or you can put 0.11. 0.1. Let me make it 11. Yeah, it's better to put a 0.11 cover. Oh, now it's changing the percentage, yeah. Sorry. Okay, just put a decimal there just to make life
Well,
easier.
you got the percent sign, so 0.11, it probably rounds.
I know,
down to
but
zero.
see this choice here? If I select a number, and then 0.11. Oh, you know what? The decimal place. This makes me, hold on. That would be nice. Okay. 11%, yes. Okay. Yes, okay. Then the question is basically ask us, oh sorry, we don't need this money, okay. Okay, good. And we're interested in what? And did you see here? Okay, how about a 15? Let's find 15. Let me make it a little bit smaller. 15, okay. Make it a little bit smaller. Too small, hold on. Oh, here, okay. This is what? This column is what? And again, you have this in chapter 6, the Excel file. You go to Blackboard, chapter 6. You'll be able to download statistics abacus. There are 2 worksheets. One's for normal distribution, one's for binomial distribution. So you can download it for your own use. But as long as you input the sample size, you surveyed 80 people, you know the probability is 11%. Then I have for all the numbers here. So this column is what? To be exactly 1 person said yes. And you interviewed 80 people, right? And 15 people said yes, it's here. 50 people. Okay, this is exact. And then this column is what? The probability less or equal to, how about this number? Less or equal to what? This one is what? The probability of less or equal to 4 people said yes. Is that clear? Is 0.05 to 1. And how about this one? Less than 4 people. This column less or equal to 4 people. This one is less than 4 people. This is greater than 4 people. This is greater or equal to 4 people. It gives you all the probabilities. Is that clear? It doesn't matter question asks you. How about at most 3? Where to find? You surveyed 80 people, and the probability for each person to answer yes is 11% according to the question, right? Then what is the probability that at the most 3 people said yes? At the most is what? 3 is what? Less or equal to 3, right? Less or equal to 3 is this one. Am I right? And how about at least 13 people said yes? At least 13 people. So you find 13 first? Yes?
Yes.
At least?
13.
At least here. At least. Yes? At least. More than 3 people. More than 3. This one. Clear? Less than 3. Here. Up to range. Good. Well, all the way to 100, but I don't think the question. But you can, if you want, you can always type in the formula by yourself, right? So 2 formulas you can. There's a 1 formula you can use. Even if you look at it here, the formula I used is what? Binomial distribution, and 4 numbers. Yeah, 4 numbers. Okay. So how to find between 10 and 5, 20? Well, here, inclusive, yeah? Inclusive, that means what? You include 10 and 5, 20. If you use this table, how to do it? Can anyone tell me? 10 to 20, right? 10.
Equal to, so
Greater than equal to 10, less than equal to 20.
That 1 to the 20. 0.7279 all the way.
I'm asking you. It is between 10 and 20.
You subtract the 1 from
Okay, can we find the probability of less or equal to 20? Yes. Less or equal to 20. It's this one, yeah? 0. This one, so that's the probability of less or equal to 20. So this one includes 20, right? And then minus what? The probability of x less than 10. Am I right? Because we want to include from 10 to 20.
yeah. No, wouldn't it be more than 10 then?
No, well, because the way you use
That's right, that's the other way.
yeah. So basically, we're trying to find, okay, what is the Sorry, I have to draw this. Well, I mean, this is confusing for some
I get
students.
it now, America.
Yeah, don't worry.
Left.
But
That's right.
okay. But maybe some students are drinking the wine, fast forward the video for this part, yeah? You never know. So, have a toast. Okay, we're trying to find between x is less than or equal to 20, greater or equal to 10. Yes, including 10, 20. Okay. So what we can do is find, okay, x from here. X is basically take a value from 0 to all the way to 80, because you only interviewed 80 people. In the extreme case, 0 people said yes. Another extreme, all 80 people said yes. Okay? So what is the probability? And I have 10 here. I have 20 here. If you use, if you use, okay. if you use, instead of using my worksheet, you just want to, okay, I want to do it by myself. Then, what you can do is you can type the formula. Basically, the formula you will use is what? The formula you will use in this case, if you do it by yourself, the formula you will use is by BI what? MOM dot DIST. And this one you put here is, let's do the 21st. And what else? 10, 20, no, 80. Yes, 80 people, interview 80 people. Each person has said 11 for each person. And if you select true, so this number is what? The probability is x less or equal to 20. Am I right? This number. Then you also need to find the binomial distribution 10. But instead of using 10, you have to use 9. You know why? Because this one, it includes 10. So I use 9, 80.11, true. Then this will give me the probability x is less than 10. Less than 10. Yes? Because I selected 9. Or less or equal to 9, right? Less or equal to 9. Then if I subtract this two, the probability x is 20 or less. 20 inclusive, yeah, 20 or less here. And minus the probability x is less or equal to 9 here. So the leftover is what? From 10 to 20. Little bit confusing. Yes, a little bit confusing. Yeah, little bit confusing.
I still remember that.
Yeah, but you have to see that. Or if you're lazy, yeah, if you're trying to use my abacus, then if you use my abacus, which number should you use? Okay, here. Well, the abacus gives you everything, right? Gives you everything. So I mean, you have a lot of choices. The easiest way is what? From 10 to 20. Can you just add those probabilities together? 10 to 20. That's all. You add them together. That's 10 to 20. Because this column gives you what? The probability that x take exactly the value. You add them together. Or you can say, okay, I want to select first the probability of x is less than equal to 20. Then find the probability of x is less than 10. X less than 10 is what? It's the same as what? The probability x is less or equal to 9. Am I right?
Yes.
Yeah. But the easiest way is what? 10 to 20. You add them together. Oh, where is the total? It's here. Is there a total here? When we highlight, it gives you the total. Oh, here. Yeah. Excel gives it the. Yeah. Good. Okay.
So when you highlight on it,
Pardon?
you said when you highlight on it, it gives you a total?
Yeah. Excel gives the total.
Oh,
The
average
sum.
count.
Yeah. It gives
Oh,
the average.
sum. Yeah.
Average and the count
Average
and also
count
sum.
and the sum right there at the bottom.
Yeah.
So,
So is that clear how to use this table or whatever? So basically, if you say, okay, what's the probability that exactly five people will say yes? Then that's 5, yeah.
0.062.
Yeah. If it's greater than more than 7 people, yeah, that's here, right? More than 7. This column is what? Greater than 7. More than 7. So this column is more than 7. Okay? But at least 7, more equal 7 or more, 7 or more, then you should have this one. You just need to do a few practice. So exactly 1%, less or equal to 1%, less than 1%. Less than 1% actually is what? 0, right? Greater than 1%, greater or equal to 1%. So you do that. Okay, good. I think that should be enough. Okay. And also, sometimes the binomial distribution will ask you what's the mean, what's the standard deviation. And it's extremely simple because the mean is n times p. What is n? You survey 80 people. If 11% said yes, then 80 times 11%, which is 8.8. You round it to 9. Basically, 9 people will say yes. That's the mean. Okay. In this example, 15, you toss a fair coin 15 times. So each time the probability of getting head is 50%. So 50% times 15, so 7.5%. 7.5, yeah, 7.5, that mean. And what about the standard deviation? Standard deviation actually is also pretty easy. It's a square root of n times p times 1 minus p. P is what? The probability of success. Remember, if you interview 80 people, and on average 11% will say yes, p is 11. 1 minus 11% is 89%. So that gives you the standard deviation. So this question will ask whether it's unusual to get 120 hits. 120 hits. So what you can do is first you can figure out what is the mean, right? What is the mean? And so 480 times, yeah. And each time it's about 30.8%. So the mean is n times p. You can find the mean. Yeah? And standard deviation 10.1. Then we plus and minus plus 1 standard deviation and minus 1 standard deviation. So if the number is below these two numbers or above these two numbers, that will be considered as unusual, right? Unusual. Most of the time it's in between 1 standard deviation or 2 standard deviations. Okay, so now let's take a look at which of following is discrete. There's only one.
Number of passengers.
Number of passengers. Yeah, number of passengers. Normal distribution. So what percentage of women would we expect to be taller than 61%? What's the formula? Remember, normal distribution. Or we have but in this case, it's greater than 61, more than 61. So if we just use the formula, we have to what? 1 subtract the normal, I have it here. 1 subtract normal distribution, 61. The middle is, the mean is 64, standard deviation is 3. And this is always true for normal distribution, cumulative distribution. Between 62 and 65. So again, you can use my abacus or you can use this. Basically, figure out what is the cumulative probability for 65 and then minus the cumulative probability when x is less or equal to 62. Yeah? Between less or equal to 62. Standard normal distribution, which one? Mean is 0, standard deviation is equal to 1. 90th percentile. What's the probability? What should we use? Normal inverse 90, right? What is 90 percentile? 90 and 10%, right? 10%. So 90 is fine. I believe 90 is fine. Yes, 90 is fine. That's true. More than 50. A random sample of 500. So let's try the 500, 80.2%. Sorry, 500. What's the probability more than 50? No, 50 is fine. 500, yeah. And what's the 80.2%? 0.082, am I right?
Yeah.
And more than 50. Which one is more than 50? Greater than, it's this color, yeah? No, this color. Greater than, more than, greater than 50. Find 50, 50. So 0.0642. Yeah, zero. Or I mean, if you want, you can 1 minus. Whenever the question asks you more than, and you always what? Use 1 minus the probability of less than 50. The answer is no, because it is it's only about 1.5 standard deviation below them. And usually it be considered as unusual events if it's what? 2 standard deviation above or below. So first, for any distribution, you can figure out what is the mean, what is standard deviation. Then the mean plus 2 standard deviation, and the mean subtract 2 standard deviation. Then if the events, the counts are below that 2 numbers, either 2 standard deviation above the mean or 2 standard deviation below the mean, then those will be considered as an unusual event. Actually, I was planning to cover chapter 7 at the same time, and you see it's possible, it's impossible. Chapter 7 is another 3-4 hours chapters. So I will take my time. So you too, right? You too.
Yes.
And you have 5 hours to take the test, yes? 2 hours, is that 2 hours to take? Huh?
No, I think it's 120.
Quiz. 120? But 120 is more than enough, yeah, to take the quiz, come on.
It is not.
And I know exactly how long it takes each student, yeah? Take the quiz, you know. So, you know what I mean? Don't tell me I need more time, because I can tell from the number of, oh, sorry.
Those first quizzes
This shouldn't be recorded. Okay, see you next week.